Okay, go ahead.
Okay. So I did my connections using breakthrough, straight through copper cables.
Okay.
I connected router 0 to the laptop, also the switch to the laptop. I'm not sure, I don't know if I can do that, but that's what I did. But this is the part I had issues with, the one with the PC, where I double clicked and then it revealed the back view. I don't know if you can see this.
Sure, I can. That's good.
Oh, okay. Okay. So then turn off the power. Oh, okay. It was off before. I
Can you
think
share
that,
that part? I think we're not seeing it because a new window is open.
okay, that's what I was asking earlier. Okay, let me now. I think I can add it to my shared tabs. Okay, here we go.
Please, the others, you can just follow through. I'm also recording it so that others can get it.
Okay. Let me just stop share and we'll share. Are you seeing now, sir?
Not really. But then, is
Now?
that did we? Okay, fine. Go ahead.
Okay. So they are on by default. I turned it off. There was a port here, a LAN port here. I removed it by just dragging it off. Then I added the module WMP 300N here. This is it here. So I don't know if I can just remove it now, and then this slot will be empty. So what I did was to drag from here, then placed it here. So, and then I turned the device back on, and then I closed. So that connectivity did not get established. That's the challenge I had.
Where is this? If I may ask, the system that is there's no wireless router here.
Okay.
Apology. And then you also connected the ISR4321. You linked it up with the laptop at the same time with the switch. I don't think that's what we did. What we did was to link the two ISR routers together, and then connected a wireless router to the desktop at the same time to the switch. That's what we did. So you could take off that one and then use a serial cable to link the two routers.
The two routers. Okay. Yeah. How do I take this off? Taking off, I've just been using the undo option.
Okay, go up there. You see this arrow up here, close to the search button. You see like cancel there. Just click on it. No. Close to next to search.
Okay, next this one.
Okay. Click on it, and then go. And then go back to click ahead. Click on the next. Yep.
Oh, okay, awesome. Thank you, sir. I had a lot of issues with that. So I'm to use a serial cable.
Yeah,
to connect the two routers. Okay.
But remember, you have to turn off the ports on the two routers.
Yes,
and then add a module, a serial port module to it, and then link them up.
Okay.
You won't connect them immediately until you add the serial port.
Okay. Thank you. All right. I'm double clicking now, then it's not displaying the ports.
You should probably you'll have pressed enter. Why not press escape button?
Escape.
Okay.
Yeah. Okay. Okay. Turn off. Where is the turn off button? Okay, I see it now. So let's add this there.
Please, while she's doing this, the others, were you able to do the assignment? And I actually didn't get submission. I was wondering what happened.
After I add the module, I can turn it back on, yeah?
Sure.
I think the issue most people had is they were not able to see what was done in class. Well, that was the reason why I stalled. I wanted to do exactly what was done in class. I didn't have the access to the video, to the recording.
Okay. Oh.
I started guessing.
Oh, sorry about that. I thought maybe somebody would have done a screenshot and then get the topology. Sorry about that. Okay. So, but then with you now, we could get it right here, and then. So you.
My serial cable would this still be the straight through cable?
No, if you take console, just look beneath the console, you see the.
Okay, I've seen it. I've seen it. Yeah, this is. Okay. So I use the serial 010.
Okay.
To serial 010.
Exactly.
Okay. Then the other connection between the switch to the desktop.
You're meant to bring out the wireless router.
Wireless.
So check, go down and check for the wireless router. I think that's why your desktop is not connecting to the router.
Okay.
Wireless router. That's an access point.
It says wireless devices. Okay.
We actually wanted you to use the W300N. So still go back to, you can cancel that off. And,
okay.
Then go back, click on that wireless icon, and then you see W3N. Look at this somewhere. Have you seen it with the antenna on top of it?
I see that, yes. Okay. W3N.
Exactly.
I don't see W3N. I see WR300N.
Exactly.
WR300. Okay. That's the one. Okay. So we'll go through the same procedure.
Yeah, so you can see it's connected already. So now
yeah,
you can as well stay connected, just like in the normal lab. You can connect from the switch to the wireless router and then broadcast. So you're going to connect the cable from that switch, the LAN switch, and then connect it to the wireless router. A straight through cable. You need a straight through cable from the switch. Exactly.
No, it's looking rough. I was just
you can still. Oh, you took it off?
Yeah, I took it off. I want to just replace. I want to reposition the wireless router.
No. Okay. You can still as well connect it and then still.
Okay.
Okay. With the way it is, whichever position it is, you can still connect it to it and then drag it around and then just put it the way you want it. Okay. This is connecting because you've already enabled the desktop.
The desktop wireless capability. I did that before, so it just automatically got connected. So this will be Ethernet 1.
Exactly, you can connect it there. Okay, so what it means is that as we go on with the configuration, once you configure the router for a particular IP scheme or IP address network, instantly the wireless router will continue to dish out that same block of IP address. And then, of course, usually when I'm going to show you guys, when we get into the wireless router, you can disable the DHCP of the wireless router such that the one coming from your main router is what the system will get. Okay. Are we following what I'm saying? By default, a wireless router is meant to operate on 192.168.10.1 network thereabout, or 0 network thereabout. So that default IP address, we're saying that you wouldn't need it in a organized topology as this, because you're trying to look at your source coming from router 1. So if that is the case, then you might likely disable the DHCP of the wireless router. So for instance, we can do that. She can just double click on it. Double click on it, Esther. Let's see. Double click on the wireless router. I think there's a window. You can share that new window page. The rest of us, are we following, please?
We are not seeing the new window.
You need to stop sharing this and then share that one. Is Esther there?
Yes, I'm here. There's a way I used to just add a new window to my sharing, but yeah, it seems not to be working today. So I've stopped the share now. Then I'll reshare. Okay, this one and then. I see it now.
Okay.
No.
I think we can. Okay. Good. So here now, just go to configuration. Click on configuration. Okay, go to the GUI. Go to the GUI.
Okay.
Okay, fine. This is where you have the interface of the wireless router. So you can actually here disable the DHCP. So you can scroll down.
Okay.
Just scroll down. Okay, so you can see DHCP server enabled. Now,
yes,
this IP address you're seeing here, 192.168.0 network, that is what it will be giving out. But you can as well disable it so that the wireless router does not give out the IP address. Rather, it will wait from the main LAN router. So you can just click on disable and see. Okay, so you scroll down to save. Then you close that window, possibly go back.
okay.
Okay. So at this point in time, what it actually means is that you disable the DHCP. And once this router R1 is configured with any new block IP address, that is what the system here, the PC0 here will get. So I think Esther, from now, you can now actually double click on the router and then do those configurations, right? Like the basic management configuration of the console password, that's a user exec password,
Okay.
privilege exec password, and then the host name and all of that. So is it possible now that the rest of us can take it up from here? Am I correct? Hello? I'm talking to the general class.
Okay.
Is it possible that with this topology we have now, the rest of us can take it up from here? Or do we still have issue with this topology, as it were?
Well, first of all, let me apologize for joining the class late.
Okay, Doc, you're welcome.
I was busy with something in the school here. So sorry about that. Yeah, I think the rest of us should be able to follow from what he has done.
Okay.
Okay, Doc, the setting of the configuration is part of the assignment.
Yes, it is. It's part of it because that particular module 2 addresses the basic management configuration. That is where you give the host name, the banner MOTD. So you go back to the PowerPoint and look at all those configuration and try to see how you can carry out the same configuration on that router. That's what we did. And then also assign the IP address, just a class C IP address. I don't know if you could still recall all of that, but then those commands are there in the Module 2 PowerPoint.
Okay, sir.
Is it possible to do that? Or maybe when I'm taking another configuration again, you can follow.
Should we do it right now?
No, not now.
Probably take.
Yeah, I'm going.
Let's move on. I think everything is on the Module 2.
Yeah.
All the steps to be taken, they are all there. So all we need to do is to continue with today's own. And like I said, when we finish today's own, we should try and finish all the work around it. I think, Doctor.
Yes, I'm with you.
I thought in the syllabus you sent, you said if we work for some days, we take a break and do some assignment. Is it possible that way?
Actually, it would be best that as we're going, you're doing the assessment at the same time.
Yes, because I want a situation where all of us should be able to complete these 1, 2, 3 before the next class.
Yes, and the good news about this is that you actually have 3 chapters coming together. That's 3 modules coming together as one exam.
Yes.
But that's a little bit tricky because if you actually want to make justice to it, it means that you have to read all 3 before you take. I mean, to go, you need to, do some reading. You already have the curriculum. I'm only just in the PowerPoint to summarize this. Yeah. That was not a problem. Please just send it to me from the iPad.
Okay. I did not tell me the number that
Am I communicating?
Yeah.
Doc, am I making a point?
You're wrong.
Doc, Dr. Daniel. Dr. Barry?
Yeah, it looks like Dan is out.
Yeah, sorry. Can you come again with that?
Yeah, I want to suggest that since we are a team, when we go out on assignment, we should try and create time and support each other wherever we're having challenges before the class. So that now we have spent almost 20-something minutes to look at yesterday's work.
Okay.
So it should be what all of us do not do, and we bring it to you to solve for us. Am I communicating?
Okay, I think that's beautiful.
So we'll continue to work as a team.
Okay, that's fine. So that means if we're meeting 1:30, you guys can meet maybe 30 minutes before.
No, even earlier, even then we finish class today, now maybe later in the night we can talk about it. And when we have issues, we resolve. Then we now know what we cannot explain to ourselves well, and we'll bring it to you.
Okay, I think that would
for me, I will just work in the background. I will not do as if I will know anything or much. We just so that we see how some trickish questions that we were not, even people like us have not thought about, can come up, and we can bring it to the table.
Okay, I think that's beautiful. So
yes.
Esther, you can stop sharing. So while I just start.
So we can just continue with today.
Okay, sir.
And to wrap that up, Doc.
Yes.
I don't know. So tomorrow we are going to have class, Abby?
Yes, we're going to have class.
Okay. Let's go.
Oh, are we getting tired of these everyday classes?
We're not getting tired. We just want a situation where
okay, I can give a day off.
This assignment. Yes, we should be able to do this assignment.
Okay, fine. I think after today's class, we'll have a break and then meet Friday. But I think we have 2 weeks to finish.
Yes. Yes. So we have mastered it now, all this teaching. And I've sent you an email that you can read to all of us now. We just send something there, you come to all of us. All the modules, even more than the chapter 3, can come to us so that we would have read ahead. And when you come in, you just explain.
Okay. It means that I can begin to give you guys some lab activities to do while you do that.
Yes.
Yes. Excuse me, sir. While the idea you brought up is very, very good, I just want you to also bear in mind that when Baze activities starts for the semester, that is when we start lecturing, it might get hectic. So let's keep time in mind. Even though we're going to get breaks, I would suggest that it shouldn't go more than 1 day in between the modules.
Yes.
That's what that. In fact,
finish up
the same way the heat you're going to face over there when the student resume fully is the same heat I might likely also face down here too. So that's the reason why I felt it is necessary that since the school is just resuming, we just go very fast so that you know that okay, you finish this and then you have all the recordings as it were. I'll make sure you have all your recordings so that you can play the video at your own convenience. If possible, I wouldn't mind and that at least we just add one or maybe 2 extra days for you to round up all your activities then for your final exam so that you won't have issues with pending assessment. So it is better we just take it as we go so that when the school will be resuming fully or when the student will return fully, you know the too well that you've gone far. Or is that not okay? If it's not okay, then
okay, whatever you decide, that will be okay.
But I still want to work at the same pace you want us to work because the truth is that this is the CCNA class one, CCNA one. Once you get it right at this stage, subsequently you don't have any issue.
Yes, that's my concern. I don't want any of
for those who are new in this area.
Yes, I don't want anybody to begin to feel as if it is difficult.
Yes, because it's not actually difficult. It's just the time you need to.
Yes.
Like me, I'm very new in this field.
But you're doing well now, and you're the one doing all this now. We're seeing, so it's a very good way to start. So.
Okay, what I will do, I will be in school tomorrow morning. If, we can come together and iron out some of this little thing for anybody that wants to come.
Okay, sir.
Okay. Okay, thank you very much. So today we'll be looking at module 3, which is protocols and models. Also have it at the back of my mind that there was a question raised by Tilatu to also address the IPv6 and all of that. So I'm trying to make up time to show us that because we need to get all this right at this CCNA one so that subsequent classes you won't have an issue. Okay, so here we'll be looking at protocols and models. Network can vary in size and complexity. It's not enough to have a connection device. We must agree on how to communicate. So you need to have a protocol. When we say protocol are order of rules or set that guides a particular operation. So those rules as what define the protocol. So you're going to have a number of protocols in the course of your carrying out this CCNA. In fact, in the course of the CCNA class, you must definitely understand protocol. So if you're doing DCP, for instance, there's a protocol that guides DCP. And that's why if somebody wants to learn networking, you must know that everything you do in networking is guided by protocol. So if I want to configure a LAN, I must understand the LAN protocol. If I want to configure probably some security, I must understand the protocol for that security. And that's why you have different commands addressing different issues or tasks, as the case may be. So when you hear this protocol, it's just a way of trying to tell you that for every stages you find yourself, you must get certain commands that will enable you to establish that particular task. So once you're able to understand protocols guiding each of them, then you don't have a problem. There are 3 elements to any communication. Of course, the sender, the receiver, and the media. So in module 1, we actually talk about media. We looked at fiber optic cable, we looked at copper cable, we also looked at wireless. These are actually media for the part of communication. And so for the source and the receiver, you agree with me that you're looking at your host device, your end devices, and then you're also looking at a number of items around that area, which includes your printer, your IP phones, and all of that. communication protocols. All communications are governed by protocols. That is what we have said. And protocols are the rules that communication will follow. And this rule will vary depending on the protocol. And not until it is established, you might not have exchange of information. So protocol must account for the following requirement: identify sender and receiver, common language must be there. We're looking at the normal human communication here. And then, of course, speed and timing of delivery also comes in. And then confirmation of or acknowledgement is also required. Dr. Barry, who is also taking this course on data communication, will agree with me that this is actually very essential when it comes to that area of communication. So common protocol must be agreement and include the following: message encoding, formatting and encapsulation, message size, timing, and delivery options. So these are actually the protocols that agree when you send an information from point A to point B. And the best way to actually understand this communication proper, each time I explain this, is that I think we quickly need to go and look at the TCP/IP model. But right before we do that, it will be necessary I explain this part, even though we've explained it before. Let me take it there. Okay, fine. This area, that when you have the rules for messaging, you have what we call the unicast, the multicast, and the broadcast. In the unicast is when it's one-to-one communication, and when it's multicast is one-to-many, and when it's broadcast, you're saying it's one-to-all. So it means that if you're doing multicasting, you're actually looking at a targeted group of systems that you're actually sending this information to. And then when you're doing broadcast, you're actually sending to all. So broadcasts are used in IPv4, but they're not an option for IPv6. Later, we'll also see Anycast. So you have Anycast as an additional delivery option for IPv6. So you have Anycast in IPv6. You don't have broadcast in IPv6, but you have broadcast in IPv4. So if you look at the IPv6 scheme, of course, like I told us last time, is 8 extent. You have 8 extent, and each of them is 16 bits. In all of that 16 and that 8 extent, you don't have any broadcast address. So the only thing you could have is what we call the subnet. The subnet, and the subnet for an IPv6 is actually the 4th extent. So that means if you have a block of, you have 16B, 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 the 4th one is the subnet. So IPv6 is quite very simple, easy to use, because you don't do a lot of maybe calculations or manipulations there. Rather, you just work with what you have. So I want us to take note that you have unicast one-to-one, multicast one-to-many, or group of targeted systems, and then broadcast is one-to-all. And that's just kind of an example to show here with that topology. Okay, so looking at the network protocol, is a set of rules, like we've said, and can be implemented on devices in software, hardware, and both. Protocols have their own function, they have their own format. So if you're sending information from point A to B, definitely it has to go through that encoding process. So when we say encoding, we're talking about that's will be broken down into smaller forms. Is that okay? And then when it gets to the destination, it has to be decoded. And that is the process in which you have to send information from point A to point B. Okay, so network functions. So devices use agreed upon protocols to communicate. And let's look at the function here. 1, addressing, identify sender and receiver. That means every sender must have an address and every receiver must have an address. And the address we're talking about is that you have both your IP address and your MAC address. for the IP address is actually divided. I'm going to still talk about, like I said, I'm still going to eye on that as well. Very important before we do more configurations on some of the topologies. For the IPv4 is actually made up of 5 classes, class A, B, C, and D. We have class D as reserved for multicast. We just talked about multicast. And then E is for research purposes. So the only one you work with oftentimes that you use on your LAN network is A, B, and C. And from A, the normal class A IP address is usually from 0 to 127. And for B is actually from 128 to 191. You can take that down. And then for C is from 192 to 168. Sorry, 192 to 223. So you have A, B, C, 0 to 127 class A, 128 to 199 class B, and then 192 to 223 class C, and then 224 to 239 is actually class D, and then class E is 240 to 255. So these numbers I just mentioned are actually numbers from that's from 0 to 255, and it means that, yeah.
Are you showing something?
No, I'm only just saying this off the PowerPoint here so that you take note that the IPv4 is actually classified into 5 classes: A, B, C, and D.
Okay, but that is not currently being displayed right now.
Yes.
Okay.
Because it's not in the slide. I'm only just saying because we're looking at addressing. So systems are meant to have numbers as identification, and these numbers could be from IPv4 or IPv6. So when you say IPv4, that's a mode of addressing those numbers you have for connectivity. So that's for two systems to be able to send information across the network. They must actually operate either as an IPv4 or as an IPv6. If you don't have that scale, you'll not be able to send information across. So I'm only just saying that so that we can add that to whatever we're doing. But like I said, I'm going to actually do that explanation further as we go on in this course. Is that okay? And then another function is reliability. The network here, looking at network protocol functions, network must be reliable and provide guaranteed delivery. Remember when we talk about requirements, we mentioned that long ago, requirement for any given network. It's also part of it, must be reliable. And then also a part of the protocol, flow control. And what is flow control? Ensure that data flows at an efficient rate. The flow control actually check in. So when you're sending information from point A to B, you need to see, sometimes you look at it, the system A might say, oh, if I'm sending at 30, maybe 2 kbps, it will take 30 minutes. And after a while, it will say again, you see maybe 3 kbps, and then maybe sometimes to go up, it will come down. That variations you're having is the flow control, trying to ensure that data flows at an efficient rate based on, and then this is also dependent on the throughput of the both devices. Sequencing uniquely labels each transmitted segment of data. As you send information from one system to the other, it actually goes through what we call sequencing. And it means that it is broken down into what we call segments. Data are broken down into segments in the course of transmission. And then when they are broken down into segments, what we are saying is that our uniquely label of that transmission is referred to as sequencing. And then error detection. It also determines if data becomes corrupted during transmission. We're also going to see that as we go on, because there's also error detection and correction. So the normal network, under network protocol function, is that it has the ability to also detect error. And then our application interface. process communication between network applications. This actually sits at the application layer. So you have all these as functions under network protocol. That means every network will operate under this. You're meant to have this as part of the protocol that defines the network. But to understand this further, if you look at the right-hand side where you have the HTTP, TCP, IP, and the Ethernet, this is what we actually refer to as a TCP IP model. This becomes a model that was put together by the US military, I think, during one of the world wars. And exactly that's the Department of Defense. They came up with this protocol. So you have here, you have like 4 layers. You have the Ethernet, you have the IP, you have the TCP, and then you have the HTTP. So this is like an interaction. In the next diagram, you'll be seeing under the rail, you'll be seeing the Ethernet here, and the IP here is the network layer. And then the TCP here is where you have the transport layer. And then the HTTP is where you're going to see the application layer. But we're saying this is the protocol interaction. This is how it interacts. You have the HTTP, which is at the application level. It governs the way a web server and a web client interact, as it defines the content and format. And then if you go down, you see transmission control protocol, which manages the individual conversation. So it's more or less like the transporter that takes information from, from the source to the destination and all of that, and then ensures what we call guaranteed delivery, end-to-end connectivity. And then it manages the flow control, that is from the source to the destination. That happens at the transmission control protocol, where we have the transport layer. So I'm going to show us that in the subsequent slide. And then we have the internet protocol, which is the IP. This delivers messages globally from the sender to the receiver. And that is where you have either the IPv4 or the IPv6, which belongs to the network layer. And then we have the Ethernet. The Ethernet delivers messages from one NIC to another NIC. So remember, the NIC is the network interface card, where you have your normal network ports. But we're saying here that whole connection between the NIC of one system or the NIC of one networking device to another is actually referred to as the Ethernet. So when you talk about Ethernet, you're also looking at LAN connection as well. So that interface that provides that connectivity can also be referred to as the Ethernet. Then let's look at the protocol suite. Remember, there must be a standard for communication. So here, network protocol suite must be able to work with other protocols. And what it is, a group of interrelated protocols necessary to perform a communication. Remember, the first one we're looking at protocol interaction. So here now you're looking at a protocol suite. So whatever suits or standard that must come must be able to help to interact with other protocols. So set of rules that work together to help solve a problem. The protocols are viewed in terms of layers. So we have what we call the higher layers and the lower layers, concerned with moving data and provide services to upper layers. So under the network protocol suite, you're looking at actually how information or how data is transmitted from the lower layer to the upper layer. And they all have to be in agreement to ensure proper communication. That means each layer must have some relationship or agreement with the upper layer, or probably the next layer that it's connected to, for a proper communication channel to be set up. So there are several protocol suites, and this is what we have here. So if you look at what I have on the screen, you agree with me here that this, what you have is TCP IP layer name. You have the application, transport, internet, and network access. So this protocol suite is actually 4 layers, It starts with the network access, the internet, the transport, and application. So what happened at the network access? A network access is where you have the Ethernet, the app, and the wireless LAN. So at this level here, it's telling you that at this level you have your Ethernet, which is where you have your NIC. It's also telling you that the address resolution protocol, which is what we call the app, is also at this layer. And then your wireless LAN, which is also dependent on the Ethernet, is also the layer of the network access. So this is a model that you're meant to work with, the TCP/IP model. And then next to it is the open system interconnection protocol. This was put together by the industry, so it's a standard. It's a standard, and the International Telecommunication Union, ITU, as well, uses as standard. So it's a standard for looking at how communication is meant to move from one layer to the other. In the case of the TCP/IP, we have 4 layers from what you can see here. But when it comes to the OSI model, we have 7 layers. So if you see each of these layers is a breakdown telling you the activities that happen in each of them. You can see here when we're going from down up, you can see at the internet you have the IPv4, the IPv6, like I told you just about, and you have what we call the ICMP. ICMP is Internet and Control Message Protocol, which actually you use for we call it for echoing. So when you're actually pinging from one system to the other. And then you can see the next layer, which is the transport layer. And what is happening here is the TCP stroke the UDP. So at the transport layer, you have the transmission control protocol and you have the user datagram protocol. These 2 protocols you're seeing are actually meant to take care of 2 different activities. Your UDP actually handles your voice and video. When you watch movies online, you're actually using the UDP. When you watch maybe live football, you're using the UDP mode of communication on the transport layer. When you're sending the normal text messages through emails, you're using the TCP, and that is where you have a feedback. So with the TCP, there's a feedback. With the UDP, there's no feedback. So we say the UDP is connectionless, while the TCP is connection. So what it actually tells you here is that there's feedback in TCP, there's no feedback in UDP. So UDP is one directional. And then the application layer, you have the HTTP, which is on port 80, you have a DNS, domain name service, you have the DHCP, and then you have the FTP, which is the file transfer protocol. So we're saying that these activities, when you carry them, you're doing it at the application layer. So this is actually for the TCP/IP model. And then we have a model also for Apple Talk, which is proprietary suite, specifically for Apple. And then we have the Novell and Netware, which is developed by Novell Incorporation itself. But the 2 that actually are available for, that are open-ended that we can have access to is the TCP/IP and the open system interconnect. So based on the curriculum, these are the 2 that you might be dealing with, because those are 2 that actually are available. Okay, so this is the TCP/IP. The TCP/IP protocol example, you can see what we have here. You can see it's almost something we just discussed about. So this is a typical connection to show that from your PC to the internet to when the message is being sent to the server. So it means that this PC here is trying to send a message to the server. Likewise, the server will have to respond to the PC, and it has to go through the internet. So it means that if I'm talking at the network access, I'll be looking at this cable part of the connection here. That's at this desktop. Same thing with the server here, the web server. And it's telling you that when it goes up, the next thing it goes to the internet layer. And from the internet layer, it has to be transported. That's a transport layer. And then when it gets to the server, in the server, it will go there as a form of an application, because that is where the application will finally load up on the HTTP. So you're going to see maybe on Facebook page or on Google and all of that, that will display. So directly on your system. So what this TCP/IP is telling you that from the time you send an information to when it's being received and when it's sent back, it is through this whole standard of protocol as a protocol suite. So it must actually conform with the TCP/IP model. There's no communication that is established on the internet that must not go through these processes. So you must actually understand this and be able to explain to your student that every communication on the internet must actually go through this standard protocol suite, either as TCP or as the OSI protocol suite. So the most common network access layer is the LAN protocol protocols, Ethernet, and the wireless LAN as a case here. So this is the TCP/IP protocol suite. This is an expanded format of it. And then this is the communication process. If you look at what we have here, it's still actually a breakdown of what we have here. Here, what is just trying to open up here is that if this is the server, and then communication is meant to go maybe from, in this case, from system to server, and then, server here, from system to server, and then when it's coming back. So if you look at the diagram, you will discover that you have Ethernet, IP, TCP, and then data. And then you see Ethernet, IP packet, TCP segment, and user data. Now, looking at this, remember the first layer is the Ethernet. The second one is the internet. And then up you go transport, and then the application. At the Ethernet level is actually in bits, what we call in, is actually in bit sizes, or in some cases is in frame, because the Ethernet layer here actually takes care of both your bits of zeros and ones, that's your signals, and then put it in the form of frame. So we are saying at the Ethernet level here, you're going to have this kind of signal of bits and zeros. That's what you can see here. And then when it goes up to the next layer, it will encapsulate. So here, it said a web server encapsulating and sending a web page to a client. That means it's from the server to the client. And how does that happen? If it's leaving from the server to the client, it means that it's going to go through from the Ethernet to the IP, to the TCP, and to the PDP, and to the data, which is more or less where you have your Ethernet. So it means that at the application level, it is seen as data. And then when it comes down to the transport, it is seen as segment. And then when it comes down to the network or the internet, in this case, it is seen as what? Packet. And then when it gets to the Ethernet layer, it becomes frame. Here you see it as Ethernet frame. The process in which this data is broken down from one form to the other, it is called encapsulation. So we will say, okay, that data is encapsulated into segment, from segment to packet, and from packet to what? Frame in this case. And then if it's also now, if a client is going to receive that information, hello?
Like we lost your voice.
Oh.
Yes, so
At what point, please?
at the Ethernet layer 0s and 1.
Yes. So what I'm saying, at the Ethernet 0s and 1s, here you have it as frame, because at the Ethernet layer, you still have the bits of 0s and 1s, encapsulating into your normal frame. And then when it's going up the layer, which is the next layer, which is the internet layer, it becomes packet. And when it's going up to the subsequent layer, it becomes segment. And then finally it becomes data. So it means that, and that's why we said that this data must be broken down into smaller forms. So the process in which it is broken down into smaller forms, it is what we call encapsulation. And if a client is going to receive any information, we said a client de-encapsulate the web page for the web browser. It means that, remember, as it's going through one layer to the other, it has to go through that process of recognition. That means at different layers, it will be recognized based on the UDP of that layer. When we say UDP is like a unit. When you say an SI unit of data at one level, the SI unit of data at the Ethernet frame, at the Ethernet layer is in bit and frame. And when it gets to the internet layer, you say the UDP, which is the user data current protocol, which is also referred to as the SI unit of data at that level, it becomes a packet. And then you now say the UDP of data at the transport layer is known as segment. And then when it gets to the application layer, it becomes data. So this just tells you the different forms in which data is being represented at each of these layers. Okay. So let's look at standard organizations that actually help in ensuring regulating these activities on the internet. We have the IEEE, we have the INA, we have the IETF, we have the ICANN, we have the ITU, and then the TIA. Now, these are bodies, standard bodies that helps to regulate activities on the internet. And of course, most of us know about the IEEE. And I also mentioned the INA and then the Internet Engineering Task Force also. So these are the different bodies we have that ensure that their standard is being maintained when it comes to communication. Okay, so I would just take us to, okay. Then the Electronic and Communication Standard, the IEEE, like we said, Electronic Industry Alliance, what the roles they play when it comes to standardization. For Electronic Industry Alliance, they develop standard relating to electrical wiring, connectors, and the 19-inch rack used to mount networking equipment. They come up with that standard. And then the TIA, they develop communication standard in radio equipment, cellular towers, voice over IP devices, and satellite communications. And then for the ITU, they define standard for video compression. They also look at internet protocol television and then broadcast communication such as digital subscriber line. So you could see the roles that each of these body plays. And then you also agree with me that everything here is also interconnected. It means that these people may ensure that everything that is being produced must work with the standard so that it will be in agreement with the TCP/IP layer or the OSI layer. So here you're actually meant to do research to research networking standard organizations. Okay.
You're off again.
Oh, I'm off again. What's happening here? So 1 minute, let me check something. So you lost me before this slide?
The voice is lost. Okay.
Hello.
Yeah, welcome back.
Yeah, thank you. I think I was just trying to check to be sure what is happening in the network. We have a very funny weather up here. Okay, so you actually meant to, I think I lost you guys where at this point?
Before here, just before here.
Okay, here.
Okay. You arrived in up here, yes.
Okay, so I said these are the different organizations that actually maintain standard when it comes to how information moves from one layer to the other. So if you look at what they do, you realize that they also have to look at the standard for each of the equipment that must be deployed to that layer. Because if that is not regulated, there's going to be a problem. Because I remember we said something that everything is governed by protocol. So it means that whichever one IEEE must regulate, ITU must regulate, must be in agreement with the standard of the layers, or else if they cannot be able to exchange information or understand the protocol of communication, then at the end of the day, you're not going to have an agreed system where one layer and the other layer must be in agreement to be able to pass on the information. So if information is going to move from the Ethernet layer to the internet layer, we're saying that every equipment that must be produced at the Ethernet layer and that which must be at the internet layer must be in agreement. And that agreement is the protocol. And that protocol is going to be governed by a certain standard. And that standard must be provided by the different bodies we just mentioned. So the benefit of using layered model, if you look at what we have here, this is where you now see the OSI model. So you can see the application, presentation, section, transport, network, data link, and physical. Please, this is the OSI model. And to your right is the TCP IP model. So if you want to look at the differences, it's trying to tell you here that at the application layer of the TCP IP, you have application, presentation, and
I think he's back.
yeah, hello, can you just give me like 3 minutes? Let me just check this network here. Hello? Can we hear me? Hello, can you hear me, please?
Yeah.
Okay.
Okay, I said just give me 3 minutes. Let me change my network, please.
All right.
Yeah, please. Thanks.